Good morning, Honors Math Tube. Sorry I'm not here today. Kind of had an emergency with my daughter, and so I made this video to help you. Please do not turn in 12.4 right now. You will turn in 12.4 and 12.5 tomorrow, Tuesday, and I'll go over all the questions on Tuesday. We will not take the test till Friday, so you guys know. We'll take the Unit 12 test on Friday. Okay, so get out 12.5 notes, the last notes of the year. Okay, last notes of the year. Much easier than 12.4. Okay, we're going to talk about probability models, conditional probability. Okay, so at the top of your notes, you are going to see a two-way frequency table definition. A two-way frequency table is also called a contingency table, and it usually displays data in two different categories. Well, helps you really organize it. It helps you identify sample spaces. What we did with the dice, with rolling two dice, and somewhat with the cards, was a two-way table. Okay, so it's going to help us do probabilities. Okay, so let's start with the first one. Pretty easy one. Here's a two-way table at the right. It shows the number of female and male students at a grade level prom committee. Okay, so there's a prom committee. They have juniors and seniors on the prom committee and males and females on the prom committee. What's the probability that the member of the prom committee is a male who is a junior? So basically what that means, we're looking for the probabilities of male and a junior, or a junior and a male, whichever way you want to think about it. Now, and you might think, oh, that's multiplication. It's also overlap on tables. So instead of thinking and is all multiplication, it is the overlap of both of them. So first of all, how do you read this table? Well, first of all, you want to realize that there's 12, because we're going to be doing a table in a second. So there's 12 total members. And if you add the juniors and seniors together, you get 12, and you add the males and females, you get 12. It has to go that way. So if we want a male and a junior, we are basically looking for the overlap of both categories. And that is 3 out of the 12 total, or a fourth of the students that are male and juniors. Super easy, just learning how to read this table. Okay? New table. Let's talk about number 2. Number 2, you have a table, and you are going to, and obviously I'm not here, so you're not going to try this. I'm just going to go through this. We're going to look at the probability from this table at a soccer camp. These are 6th, 7th, and 8th graders that came to the soccer camp, boys and girls camp. Total of 50 players came to the camp. Okay? We're going to look at probabilities of 8th grade boy. So again, that's and, 8th grade and boy. So we're looking for that overlap. And then we're going to do 6th grade and girl. Okay, so 8th grade boy, we're looking at the overlap right there. So there's 10 out of 50. Pen is dying on me, which is 1/5. I'm going to go grab a new pen while you guys are looking at that. And then on the next one, as I'm walking back, make that a little darker for you guys. We want to make sure everything is reduced. It's easier to forget to reduce on these, but you should reduce. 6th grade and girl. Now we're going to look, okay, 6th grade, girl, we're looking at that. 8 out of 50. Again, reduce it, 4 out of 25. So that's what, a two-way table is. Okay, at the bottom there is a two-way table that's not completely filled out. We're going to fill this out so that we understand how it's filled out, and I'll give you a better idea how it works. So 100 freshmen and sophomores were surveyed whether they are involved in co-curricular activities. This is the answers, but it's incomplete. We know there was 100, which makes sense what they said. We see 55 sophomores, so we can go right to here and know that that has to be 45 to make a total of 100. Okay, we don't know these, but then we could fill this in. If there's 28 freshmen and that said yes, they were in co-curricular, and a total of 45, this must be 17 to get that total of 45. Then we can go down here we know that's a total of 31 that said no. Then we could go here, this has to be a total of 69 that says yes, so you get 100. And you could do this in multiple ways. You could say if there's 14 that said no out of 55, then there has to be 41 that said yes. And then you can double check. Does that 41 give you 69? Yes. Does everything give you the right totals? So just to kind of an idea. Okay, turn the page. So we're going to talk about something about conditional probability. So a probability that an event will occur given another event has already happened is called conditional probability. Has some condition to it. We're not looking at the whole table. We're looking at a focus of one part of the table. Okay? You can write a conditional probability of an event B that given that A has already happened by this. Okay? This means your new denominator. And I'll show you when we get to a formula in a second. Okay? So you read it. Conditional probability that B given that A has already happened. So probability that it's a girl given that you know it was a 6th grader. Okay? Not everybody. So you're really narrowing your focus down. This is the formula that you want to use. So if it's the probability that A and B are your two events, the probability that B occurring given that A has already happened is B slash A. That slash kind of looks like a denominator in my head, so I'm thinking, I got to change my denominator. The numerator is both things happening, the overlap. The denominator is just what is after the slash. New denominator, not everybody, just that focus. Okay, so let's see if we can do that. Take a table, pretty easy table. I'm going to skip that part, and we're going to go to this table right here. Okay, so we're going back to that 6th grade camp, 6th, 7th, and 8th grade soccer camp. We're going back to the same table, and now we're going to do some conditional probabilities. I want you to see there's slashes, 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 slashes. So we're not looking at all 50 people. So the way you read number 1 is the probability of a 6th grader, given that you are looking at it's already a boy. So you're only looking at boys. So when you're talking about it, you're only looking at these 23 students, not everyone. And out of those 23 students, how many were 6th graders? Well, 7 out of 23. So you notice your denominator is not 50 now, because you're narrowing your focus to a different part. Okay? 8th grader, given it's a girl. Okay, so we're only looking at girls. 8th graders given a girl. Basically, is the overlap. It's a girl and an 8th grader. It's that overlap of those two. So 12 out of 27 now. That reduces by 3 to be 4/9. Okay, 7th grader given a boy. So we're back to the boys. 23. Now we're looking for 7th graders that are boys. 6 out of 23. Okay, I want you guys to notice these are different. This one says a 7th grader given as a boy. This says a boy given as a 7th grader. So denominator is going to change. The denominator is not going to be 23. How many 7th graders are there? Well, yeah, there's only 13 7th graders. Out of those 13 7th graders, how many were boys? 6. We already knew there were 7th graders and boy was 6. But now we're focusing on just 7th graders. So again, whatever is after the slash, that's your new denominator, that total, and that's the column or row you are looking at. Okay, number 5, very important. 6th grader given it's a 7th grader. Okay? Well, for this to happen, you have to be able to be both a 6th grader and a 7th grader at the same time. These are parallel to each other, so this is a probability of 0. It is mutually exclusive. So one more time, remember that the numerator is both and. You can't have and. You can't be both grades at the same time. Okay, when you're done with that, turn the page. Okay, so last thing. This It's going to be on your homework. It's going to be on your test. It's going to be on the final, a table very similar to this. So if we're reading this table, this is cars and trucks and vans. So, and you have one color. Okay, so there's cars, trucks, vans. You have black, silver, and white. Out of this survey, 2,200 total vehicles were in the survey. Okay, you're going to notice some says or, some says and, some says given. So there's a lot of things going on. Again, this is how it's going to be on the test. So remember, or is add, and is overlap on a table, not multiply. It's the overlap. Okay? And slash means given. Just give you a couple of things to think about here. Okay, so first car or white. So we're going to remember anytime we're doing or, it's going to be the probability of car plus the probability of white. And if it's not mutually exclusive, then you have to subtract the probability it's a white car. So white and car. These are not mutually exclusive. And the table is the best way to see it because I can see an overlap. So we're going to go to cars. Okay, well there's 100 cars. Or means add. There are 100 white, so that'd be 200. But as we're going through this cars and white, we have an overlap of white cars of 52. We cannot count those white cars in both white and car. We can only count in one category. So we're going to subtract that overlap. This is out of 200. It's everything. So we get 148 out of 200, which reduces by, I believe, 4. So 337 out of 50. And remember, there's a button on your calculator that can reduce for you guys. Okay? Same thing on the next one. Black or truck. So let's go to the black. So if you go here, black, there are 80 that are black. Okay? Any type of vehicle. Or means add. If you go this way, there's 68 trucks. But as we go through this, we counted that overlap of 28 twice. We can't count it twice, so we're going to subtract the overlap. And that gives us 120 out of 200, which reduces to be 3/5. So 3/5 of the vehicles are either black or a truck. Okay, next one, car and white. Again, you can't multiply in a table, but this is the overlap. So we're basically looking for what I looked over here, a white car. How many white cars do we have? Well, remember, white cars was that number I circled before, 52 out of 200, which is going to give me 13 out of 50. Okay, same thing on D. Black truck, already have it circled, 28 out of 200, 7 out of 50. Okay, kind of done with the or part till we get down to here. Van, okay, not a van. Well, it might be easier to figure out how many are vans and then subtract them. So if you look at it, there are 32 vans. So we're just going to go 200 minus 32 over 200. That gives me 168 out of 200, which reduces to be 21 over 25. You notice I reduced by 4 a lot. Okay, again, and means overlap. So let's go to the next one, truck and van. Well, can a vehicle be both a truck and a van? That'd be a pretty ugly vehicle. Maybe a Cybertruck. Doesn't overlap. So this means it's mutually exclusive. The probability is 0. Okay? Remember, the opposite of mutually exclusive is overlap. If you don't have an overlap, then your probability is 0. It can't happen at the same time. Okay, So we did a lot with overlaps. You're going to notice on the next one, G, car or truck. So we're looking at cars or trucks. They're parallel to each other. There's no overlap. They are mutually exclusive. I'm going to put mutually exclusive. So I don't have to worry about overlap. I just add the cars, 100. I add the trucks, 68, out of 200. And that reduces, we think we had it already here, 168 out of 200, which is 21 over 25. A car or a truck is the same as not being a van. Okay, next three you got to pay attention to, and then we're almost done. We're looking at this question, not a truck or a car, given it's not white, black or white. Okay? I'm going to skip this one, cancel it out, and we're going to go to the next one because you're going to see that problem go back up. So, let's go to this one. Same table. We're going to do I and J. So, cancel out G, or H, I'm sorry. Cancel out H. So, if one car is chosen from a lot, what's the probability it's black given it's a van? So, now we're not looking at all 200. We are just looking at vans. Again, this last part right here is your new denominator. So we're only looking at vans. There are 32 vans. Out of those 32 vans, how many were black? 16. So it's always focused. The numerator is going to be van and black. The denominator is going to be what you're trying to talk about, which your nervous focus, it has to be a van. So half the vans are black. Okay? Same thing on here. Van given that it's white. Okay, so we're only focusing on white. There's 100 white vehicles. Out of those 100 white vehicles, how many are vans? 14. So again, the overlap is the top, white van. The denominator is just white. So that reduces to be 7 over 50. Okay? Okay, once you're done with that, you're done with the notes for the year. Woo-hoo! And get out worksheet 12.5. I'm going to walk you through a couple things, or star a couple things that are always missed. Okay? Pretty easy, the first one. It's talking about exercising, did not exercising, and getting a cold and not getting a cold. This is how many, it's not a probability. People miss that all the time. So if you're going ahead of me right now, you might want to listen to this part. This is a total, not a probability. Probability is between 0 and 1. This is a given. So if I'm doing number 4, how many people did not exercise given they didn't catch the cold? You're only focused on those 32 students or 32 people. Out of those 32 people, how many didn't exercise? Same thing here. This is a given. So be very careful. Okay? Same thing on the bottom table. This is tennis and not playing tennis. Again, the last one is a given question. So is this one, so you guys know. It's a probability that chosen has played tennis given it's a boy. So it'd be tennis given it's a boy. Okay? Turn them to the back. Number 10, you're going to be, what's the probability? It's the puppy selected as male, so you're given it's a puppy. This one you're given it's a kitten. Not all the pets. This one I'm sure I'm going to have to go over on Tuesday. It's a hard question usually for people, so we may talk about that Tuesday. We'll see how you guys do. And then this is another car truck question, very similar to before, but no, we're not going to be doing black, white, and silver. We're going to do red, white, and blue. Okay? Be careful. These are givens. Okay? And then, to make you hungry, you guys are going to finish this two-way table about what kind of lunch they wanted. Hamburger, pizza, or sandwich. Make sure you fill out the table before you answer this. And again, these down here are givens. Okay. So, there you go. Again, finish 12.5. Tomorrow on Tuesday, we'll go over 12.4, 12.5. I'll collect both of them. We'll do some review. Wednesday, we'll take a group quiz, review. Friday, we'll take this test. Okay, hope you guys have a good Monday, and I will see you tomorrow. Thank you. Bye.